Okay, welcome back. And this is where we left. So, while you were switching between two videos, have you been able to count how many digital twins you have? Because you have been using different social media platforms, shopping areas, and sharing your personal data and so on. It's quite interesting, isn't it? So I think you really need to be, or we need to be very careful about how much data that we are sharing, because these are an asset for different organizations. Yes, this is an asset, and also this is being used for different purposes. But now we have a new environment, Metaverse, and now we are creating our digital twin and moving into Metaverse for different purposes. And it's becoming quite important area. So what we said at the beginning, we said, okay, now how many digital twins you have? So if you look at all these different social media platforms, you can name all of these different ones. Facebook, Instagram, Twitter, LinkedIn, and so on. Plus, you have been using different platforms to shop, Amazon, eBay, and so on. And also, you have been using your mobile phone and leaving a trace of yourself. This is like a digital biomarker, and also all other different emailing and text messaging, WhatsApp, and so on. So now you may have created a digital twin for each, but if you bring everything together under one umbrella to collect everything together, all data sources, and fuse it into one data source, and then it can be used to feed into an artificial neural networks. It's an early version of deep learning or early version of artificial intelligence based on data-driven models, because it learns by itself. And then you can create one single giant replica of yourself, digital twin of yourself, with a similar behavior, similar attitude, and so on. And now they can be used in the metaverse environment, and that can be used for different purposes. So while we are talking about the data that's coming through different data sources here, and moving into artificial neural networks, and then creating a digital twin as a whole. So how this artificial neural network act here? So what it does is it collects the data or from different sets of data modules. For example, it may be text data, it may be numeric data, or whatever, from different thousands, millions, or billions of people over different time period. And this is coded and fed into a mathematical model here. So every arrow here has a weight. And now the data comes in, and these are the equations. And now this is passed on to different layers here. And then it gives you a decision whether this is X, this is Y, this is Z, and so on. So it may be recognized that, oh, that person is a good person, or that person has a brown eyes, and so on. Or it may be apple, it may be a disease, for example, is it like a cancer or whatever. So, and then you have this data collected over time, maybe over a month, maybe years or decades. Then what it does is that if this input data gives an output, so your target, so with this one, you may be able to identify whether that person is willing to buy a bag, yeah, or that person is willing to buy a cloth, for example, because you want to create a kind of personalized habit, or that person may be willing to spend time in the museum to see historical architecture. So what you do, pass all the data, go through make the calculations, and it gives you the result. If the result is not you expect, it means that it is not correctly recognized. Therefore, there's a feedback version, and then it goes back and try to make it correct itself. And now there is a learning cycle here. And until it learns everything, or until it learns up to the threshold that you set, for example, I'm quite comfortable with 90% accuracy. Therefore, you can stop it up to that threshold. And then it can learn up to that point, and then it can stop there. So what you can see here is that input layer, this is where the data is fed in, and there's an output layer, this is where you see the target. But in between, there are two hidden layers. They are being used to increase the number of nodes to learn the complex architecture, complex data. So the number of hidden layers may be increased to 3, 4, 5, even 100, maybe 600. And you can see the neurons here, and the neurons is trying to mimic the way we learn in our body. And the number of neurons may be also increased to hundreds, even thousands. So the more complex the data you have, it means the more complex architecture that you have to learn. So therefore, you need much more complex artificial neural networks you need to be able to model this data. So this is what you can see here. So and there are different versions of such artificial neural networks, mainly data-driven ones. We name these machine learning algorithms. And there are different ways of learning these based on the mathematical architecture that has been developed over 5-6 decades. And with the computational power, the way we learn and the time it takes to learn is getting better and faster. So next step, how you can utilize this in different fields. So let's have a look at the metaverse, virtual and real reality, and how would you be able to use artificial intelligence in the metaverse environment to bridge the virtual and real? How would you mimic this? How would you make it more real? Because the metaverse is trying to make it happen. So if you look at all these different use cases, you can name different things. So you are trying to, for example, we said a digital twin. So if you collect the data about yourself from different sources, if you bring everything together, you can create a digital humans and digital twins you have. And also, if you look at accurate avatar creation for different people, and also you can have an opportunity to create a model that is accessible using different languages. And also you have virtual reality world expansion at scale with as many people as you want, as many objects as you need, and as different places as you may be in. and also the other interfacing environments. But there are so many different challenges in and around artificial intelligence in the metaverse environment. So we said, okay, as many people as you want, as many places as you may be in, and as many objects as you want to see or touch or interact with. So this is a massive issue because of its complexity, time, and the data, and also the bandwidth that you need to communicate with people at longer distance. So because you want this to be a near real environment, so multi-user, multi-object recognition interaction, because of the ability of the bandwidth that you may have, and also computational resources that you may have, and also another one is ownership for AI created content. So it's like IP, intellectual property issues that you need to be very careful about. It's no longer easy to copy and paste. So, and the other thing is that you are going to create avatar for yourself in the metaverse environment. So this is you, therefore you have owned this, and how it can be resolved. And deepfakes and user transparency. So somebody just use deepfake to get you speak and tell certain things that you never told. So this would put you in a difficult position. And fair use of AI and machine learning. So it is not accessible to everyone. And how would you be able to do that? Because certain people, if they are not using, may be disadvantaged. And also right to use data for AI modeling training. So as we mentioned, data belongs to you. Data is yours. And I don't want my data to be used for certain purposes. So, but it's being used already. I think this is another issue. And also, the AI algorithm has a bias, definitely. And this has already been shown in the academic papers, academic publications, as well as on, you must have already seen on the news as well. For example, job recruitment companies have started using AI to be able to shortlist, long list or shortlist the candidates. Even they may be asking some questions through AI-driven tools. So there should be an accountability for AI bias, and this needs to be looked into very carefully. So there are good opportunities if you are used for the benefit, but also there are challenges. Actually, challenges can be divided into two areas. One is the technical challenges, the data storage, analysis of data using powerful computers, using for AI and machine learning development, and also bandwidth for internet access, for data sharing, data passing between two different nodes. And the second aspect is the social aspect. I think these are going to be two challenging umbrellas as far as this technology is concerned. Okay, yes, there are some good things happening using data and artificial intelligence. And how could you turn this into good things? Okay, now what was the project that we were running? Oh, digitizing architecture restoration using AR, VR. What would be the extent of this? So, in the architectural buildings, there may be certain parts, and it may be missing, the first thing. It may be broken, the second thing. Or you need a replica to be able to preserve this just in case. So, but how would you be able to complete the missing part or a broken part? And even if this part is very precious, then how would you be able to scan this to create a replica of this, to present this to different people? So, for example, you may have an object in a historical building, and you can use artificial neural network to learn how we may be able to uh, identify what was likely to be missing here or here. Then once you learn this based on historical information, based on the other information that you have gathered and put into artificial neural networks, then once you create it, it is near real object, because that part was broken, maybe missing. So therefore, this algorithm in 3D would be able to predict what was likely to be here. Then this would be passed on to a 3D printing, and the 3D printing would be able to print out the 3D version of this. So now we started talking about actually three different technologies here: the data and data architecture, data strategy. The second one is artificial neural networks, machine learning, the second, and 3D printing. So this hybrid model brings everything together, recent technologies, to help shape the future, and we could do things that we have not been able to do in the past, and we will not be able to do in the near future, because this technology is moving fast to help us do things. So on the screen, you can see this 3D printer. It may be a size of a bag or even long, as a size of small fridge. But now we can see a 3D printer as big as a small house, because now it's being used to build a house. So you can see 3D printed houses. So I think this is an interesting area where architectural restoration is becoming more precise, faster, and also can be scaled up. Can you imagine if one part is missing here or broken, one person who has a specialist expertise in architectural restoration would need to work on this for days, months, even years. And you may not be able to complete that part, and even you may break another part. So, but with this 3D printing augmented by data science, artificial neural networks, machine learning algorithms, would enable you to try it for as many times as you want to reach to the optimum near real architecture. Okay. So another one is, how would you be able to augment your 3D architecture restoration model by using different AI tools to give you different perspectives? For example, it may be able to give you information about the buildings and history behind this, and it can help you for restoration education, and also tourists when they visit this. For example, if you ask an AI-driven tool, Google or ChatGPT or whatever, it may, while you were modeling this or while you were self-learning, it could give you information instantly being collected from different sources. For example, about the Coventry Rune, it may give you this information. This is a rare medieval survivor of the Coventry bombing raids that happened in the Second World War. Yeah, because Coventry was bombed a lot during that time, but this building was survived. So your AI tool could bring you this information from different sources. Another one is, for example, about the use of this building. Um, uh, and of course, you can inject this piece of information into your metaverse environment. But what happens if this information is updated and you cannot do it manually? You should not do it manually anyway. This could be brought in automatically and not manually as soon as the information in the public domain is updated. The pottery finds suggest that the building may have been a late 13th century merchant's house, possibly connected with the nearby Whitefriars Monastery in that area. And another one is maybe about a specific part of the building, the vaulted cellar entrance door. It can show you what it is. So I think your metaverse environment, your education tool, your training tools can be further enhanced, augmented by a number of different AI tools that we have started seeing coming out. Another example, there are commercially and publicly available AI-driven tools available. We mentioned ChatGPT that was developed by OpenAI and recently released actually. And ChatGPT, actually, the name combines chat, referring to its chat box functionality, and GPT, which stands for Generative Pre-trained Transformer, a type of large language model that was developed by artificial intelligence, deep learning, machine learning algorithms, and so on. So basically, it has an up-to-date information. It can collect up-to-date information. It can translate it into the things that you want. So I'm sure you must have used this for different purposes, but it could be linked to your self-learning metaverse environment for education purposes, not only for architectural restoration, but also for others. Another example, it's a commercial one. Viras is an AI-powered visualization tool. It was developed at Evolve Lab, and their mission is to drive transformation in industry by leading a transition to data-driven design and computational construction. So, and they develop technology and innovation in the built environment by helping their clients leverage more efficient, cost-effective, and sustainable building design strategies. And this could also be translated into architecture, restoration, and so on. So this is just two examples of many that could be used for different purposes. As you can imagine, I give you two examples, but in different categories. One is actually a tool that can be used to develop a 3D architecture design, whereas the other one, under OpenAI, ChatGPT, could be used to further augment what you developed. Okay, another example is in the use of artificial neural networks, actually data-driven artificial neural networks for health-linked problems that we published a couple of years ago. And this is where we use convolutional neural networks to be able to recognize influenza proteins, to be able to identify to which group the influenza protein may belong. So this is an interesting area. So we collected data. I mean, without the data, we couldn't do it, but we collect data from databases. So well over I mean, nearly 200,000. And we, as we mentioned, the data comes in, and then we recognize either this is a human, avian, and swine. So the protein data comes in here as an input, modeled using a different way. Basically, the information about the protein has been turned into data numeric values. And then the output, the target is has two different outputs, human, avian, and swine. And now what we can see here is that this is trained and learned all the values. Now, if a new protein comes in, I would be able to say, oh, whether this is human, avian, or swine, and with nearly 99% accuracy. This is quite interesting. So we can increase these examples as we progress. But I'll give you more examples why data is important and where it can be used and how you can harness data better using artificial neural networks under different application domains. And you will be able to understand in your own discipline how you can use data in different settings.